to the right or to the left. So we have two possibilities. I promise I explain in a few minutes how you recognize what direction. Open. And this is horizontal, both. Right or left. And vertical. Open over or downward. How do you know that? Well, by the equations. Suppose this parabola, the equation is y squared equal 4px. In this, you see that the square, the quadratic part is in y, that immediately identifies the horizontal. And the vertical, no, the vertical is x squared equal 4py. Okay, entonces super easy the identification. Si the quadratic part, the second degree, the two exponent is in the y, because it's important to understand that the parabola is different to the ellipse. The ellipse, we have x squared and y squared. In the parabola, no. One is quadratic, another is linear. Si the quadratic is the y, is the horizontal. Si the quadratic is the x, is vertical. Okay, one first thing. The second is que the parabola, let me take, for example, horizontal. The vertex, suppose que es in the origin. This is y squared equal 4px. Entonces, important point in the parabola, vertex. In this case, 0, 0, because we have no translation. But in general, we have translation. So the equation is modified a little bit like that. Let me show you. Y minus k squared equal 4p x minus h. So you need to understand that the vertex is located always at the point h, k. Because h represents the x component, k represents always the y component. And the formula you see. In this particular equation, you see clear that x and k are 0. Therefore, the vertex is located in 0, 0. Another example that we cover here, no. It's in that way. Entonces, the vertex is located in another point. Okay. Point, important point, vertex. Second important point, focus, only one. Focus. It's different to the ellipse. Ellipse have two foci. Parabola have only one. And the distance from the vertex to focus is p. So this distance is p. And who is p? This parameter that you see in the equation, 4p. Okay? And we have one more thing. This is the vertex. Okay. Let me erase that part. This is the vertex. That point is the vertex. And we have directrix. Directrix is a line. No es asymptote, it's a line que somehow characterize the parabola. Is in this case vertical. It's vertical, and the distance from the vertex and the directrix is also p. pp. In this case, the formula for this line is x equal minus p. Depending on the problem, no? It's vertical. Vertical. So we have horizontal parabola. However, we have vertical line directrix. Okay. Now that's it. No, we have one super important idea in the parabola, que is the focal diameter. Focal diameter. What is the focal diameter? It's passing through the focus this distance. Focal diameter. And the focal diameter is equal to 4p. at that distance, F4P. So this number that you see in the equation represent the focal diameter, 4P. And it's obvious que si this is 4P, this is 2P. And this is 2P. And this is 2P, 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 no P, 2P. 2P plus 2P is 4P. In total is 4P. And this is the, and this is important point. This is the endpoints of focal diameter. And this information give me how wider or how narrow is our parabola. So one parabola get 4P is smaller, look like that, and one parabola that have 4P bigger is like that. Okay, so now when I do the graph of the parabola, we need some information. Number one information, vertex. Dependency we have or no, translation. Number two, focus. Number three, directrix line. You are doing the graph and you are doing the equation. And endpoint of the focal diameter. 4. Endpoint of focal diameter. End the story. 1 point, 2 point, 3 point, 4 point, and 1 line. Define perfectly the parabola. Clear? And we have two kinds of parabola, horizontal parabola and vertical parabola. Vertical parabola is exactly the same. Vertical parabola is exactly the same. Suppose another example. We see a lot of examples today of the vertical parabola. Suppose that the vertex is here, H, K. I forgot to say something important. No, I don't forget. Si P is positive, the parabola open to the right, the horizontal, no? Si P is negative, open to the left. I said that or no? Let me see. No. Okay. P, give me information in what direction open. Si es vertical parabola and P is positive, open up. Si P is negative, open down. Suppose que P is positive, open up. And we have here the axis of symmetry. I forgot to say that. This is the axis of symmetry. Axis of symmetry of the parabola. We have directrix, in this case is a horizontal line, y equals something, y equals b. But important thing is that depending on P is that distance, is the distance from the vertex to the focus. It's super easy to find that. And this is the same distance for the directrix. This is the same distance, PP. I'm going to find how open or narrow or wider is our parabola. You find the focal diameter and you find the endpoint of the focal diameter. Clear? Any question? Any question? Come on. No omission. Omission, no credit. Vertex. Focus. 2 endpoints for the focal diameter and directrix. End the story. In what direction open? In what direction, yeah, open. And see it's vertical or horizontal parabola. Correct? Correct? It's clear the theoretical part? Guys, answer me. Come on. Answer me.
Yes.
Okay, let's see example. Okay, example now. Let me start for the easy example. A little complicate. Example 1, say. X squared equal AY. Now what is the job? Well, the job is do the graph of this. Okay, and find everything. Find the vertex, focus, directrix, and point focal diameter, what kind of parabola it is, and why not axial symmetry. So 1, 2, 3, 4, 5, 6 things, and do the graph. Let's do the graph by hand in the whiteboard and after verification and Desmos. I sent to you the application for the conic section and Desmos. Do you see or no? And the last no. In the last video, I sent to everyone the video plus the link connected with this application. It's my application, and you can use it anytime. Okay? So if you want, I send again in this video. When I send the video, you guys send again. I don't know. Yeah, you have. I suppose you have. Okay. Entonces, help me. What kind of parabola it is? Vertical, horizontal?
Can you send it again, please?
Absolutely. Don't worry. Okay. Guys, it's important in college education to be organized. Okay? It's important, the organization. The organization helps you to understand much better the subject. But okay, I say again, no problem. Answer my question. What kind of parabola it is? Vertical parabola, horizontal parabola?
Vertical.
How do you know? What is the clue?
Because of the x square.
Absolutely. This is the idea. It's a vertical parabola. Anyone follow me so far? Immediately I compare with this equation. Okay, this is the standard, no? Entonces I see que in our specific problem for PSA, okay, that part is equal to that part. Therefore, PS2. See PS2, in what direction open this parabola? Up or down?
Up.
Up, because positive. Very well. Okay, entonces opens, this parabola opens up. Because P is positive. Very good. What about vertex? What about vertex of this parabola? Remember, the vertex is the turning point here, is the vertex. And see, you have no transformation, we have no H, no K, it's because the vertex is located at the origin, 0,0, no? Make sense? Another problem you see x minus 2 squared is equal a y plus 3. Entonces we have the vertex is located in another point, no? By the way, what point is located this parabola? At what point is the vertex? It always is h comma k, no? Who is h and who is k in this example? Who is h? Who is k?
H is 2.
Very well. And k?
K is -3.
Very, very, very well. Okay, it's like similar idea, opposite sign, and the equation to the point. Because in my standard form of the equation is x minus h squared equal 4p y minus k, no? Entonces you see, wow, this is negative, it's because h is 2 positive, because positive and negative is negative, exactly like the sample. However, k is -3, because negative and negative is positive, you get positive here, right? But in this case, no, I don't see any k, any h. So my vertex is located at the origin. Clear? Clear?
Clear.
Super. Now focus. Focus is important, guys. See, this is my parabola, and this is my vertex. The focus never is outside. It's inside. And the same axis of symmetry, and the distance is P, que P is 2. Therefore, the parabola, our parabola, look like that. Let me try. Let me try to do roughly sketch by hand, and after we check it with Desmos. Okay, I know that this is my parabola. I have my vertex, sorry, 0,0, and the focus is in on the y-axis. Okay, by the way, the y-axis is the axis of symmetry. Because it's vertical, no? Well, no, exactly, but at least it's coincident in this case or parallel to the axis, to the y-axis. And the distance is P, que P is 2. This is 1, 2. This is my focus here at the point 0,2. It's clear? And directrix is a line. It's a line. Okay, the line is y equal to horizontal line because it's a vertical parabola. Same distance, guys. That distance is P. That distance is also P. Everyone follow me? Good.
Yes.
Good. Now, focal diameter. Focal diameter is 8. Focal diameter is 8. It's 8 gets that number. Always is that number. Focal diameter. But the half of the focal diameter is 4. So from the focus, 4 in both directions, to the right and to the left. Entonces es 1, 2, 3, 4, and 1, 2, 3, and 4. That point is the point 4,2, and that point is negative 4,2. This is the focal diameter. And our parabola look like that. Let me use in green color. Okay. Remember, important point, vertex, focus, directrix, endpoint focal diameter, this guy and this guy. And you get approximately one correct idea for our parabola. Clear? Clear?
Yep.
Yes.
Huh? Yes or no?
Clear.
Clear. Okay, P2, P2. Okay, let's move on to Desmos to see more accuracy. This answer. Oh no, I forgot something, but it's okay. Okay, let me try to find conic sections. Okay, conic section example parabola. Example 1 parabola. Boom, something like that. Do you see this one? Do you see or no?
Yes, we see.
Look at the formula. The formula is x squared equal ay. However, the point you identify, wow, it's vertical parabola, no? It's vertical. And P is 2. And H and K are 0. H and K are 0. It's in the origin, H and K 0, 0, 0. And P is 2. P is 2. Positive 2. No, 2, 2, 2. No, 3, 2. It's vertical. No ellipses, sino parabola. Vertical. Boom. Look at that. Look at the famous point. Vertex 0,0, focus 0,2, endpoint focal diameter 4,2, negative 4,2, and directrix is the line y equal negative 2. Super good. Carmen, no problema.
No problem.
Okay. Let's move on to the second example. Example 2. Now it's given this equation, y squared equals 16x. And we are doing exactly the same. Identify what kind of parabola, determine P, determine vertex, determine focus, determine directrix, determine the axial symmetry, and point focal diameter. What kind? Horizontal or vertical? What kind?
Horizontal.
Horizontal. How do you know, mister?
The y squared.
Exactly. Now I can see, remember compare with the basic standard, get for px, for p is equal 16, p is 4. See, p is positive, in what direction open? In what direction open? Open, in what direction open? This parabola open, in what direction? In what direction open? Horizontal, p positive. In what direction open?
To the right.
To the right, very well. To the right. Very well. Okay. Now, what about vertex in this case? You see some translation? No. Entonces, the vertex es 0,0. Now focus. Okay, entonces now I like to do a rough sketch to understand this parabola, no? This, remember, this is analytic geometry. Entonces now I know que my parabola, this is the vertex, y open in that direction, I suppose. Okay, and the focus is located here, obviously, inside the parabola, and the distance is 4. See, this point is the point 0,0. This point would be 4,0. Because that distance is P. And directrix is a line, the same distance, but in this case, vertical line, x equals -4. Because the distance is the same. That distance is P. That distance is P. When you're talking about distance, is positive, absolute value. Absolutely, so you move into the left, it's negative, no? You move into the right, it's positive. Okay, now one more information we need, endpoint, no? Endpoint. What is the focal diameter? The focal diameter is 16. Focal distance. So the focus is located at the point, sorry, 4,0. Directrix is x equal -4. And what about endpoint of focal diameter? Well, focal diameter is 16. So the focal diameter distance is 16. How do you know? Because it's the number here. 16. And you divide by 2 in order to find the semi-focal distance. Entonces es from the focal 8 outward and downward. Entonces I suppose que our parabola no es look like that. It's more wider. So basically we get that point here. This is the vertex 0, 0. And the focal diameter is 8 and -8. in total 16. This point is the point 4,8 and this point is 4, -8. Entonces our parabola is like that. So the endpoint for the focal diameter is 4,8 and 4, -8. And what about the axis of symmetry? The axis of symmetry is the last information important. Axis of symmetry, remember, it's the axis que split the parabola into equal parts. Es obvio que the axis of symmetry is this line. Que the equation for this line is y equals 0. Axis of symmetry. End the story. Any question? No problema.
No, no problem.
No problema. Let's double check in Desmos. Of course. Okay, the way to working with this script of Desmos is, look, I go to my specific example. It's example number 2 of the parabola. Look, no 1, 2. Get this equation. You click here, you see the curve, but without information. To get the information, well, you define P4, no? P4. And the rest, H and K is 0. And you identify that we are talking about horizontal. No hyperbola. Horizontal parabola. Horizontal parabola. Boom. There you go. Look at that. Vertex, focus, endpoint focal diameter, directrix, and axis of symmetry. Axis of symmetry. And don't touch anything inside the mathematics here, because this have a lot of operation to compute everything. And you take advantage, because this basically is geometry. P distant in the direction, P distant in this direction, 2P distant in this direction, 2P distant. You can use in this, use safe the arithmetic part. Any question, guys? No?
No.
Okay. Come back to the whiteboard to see the example 3. Now you see whiteboard, right?
Yes.
Example 3. Example 3 say y plus 3 square equal -4p, no, -4, sorry, no p, x minus 2. Okay. Classify what kind of parabola we have in this problem. Horizontal or vertical?
Horizontal.
Same idea, because the y part is the square, second degree. In what direction? Well, no. Let me determine the p-value. Remember, this is y minus k square equal 4p, parenthesis x minus h, no? So you compare 4p is equal -4, no? Compare. This is this. Therefore, p is -1. So in what direction open this parabola? In what direction open? In what direction open this parabola?
To the left.
To the left. So my parabola look like that. Okay, super. What about the vertex of this parabola? Compare K and remember the vertex H, K. The only thing you should do is determine who is H and who is K in our specific example. Who is H? Who is H and who is K? Compare this, look, this and that.
H is 2.
2, H is 2. Positive 2 or negative 2?
Positive.
And K?
K is negative 3.
Absolutely perfect. Everyone follow me, guy? No big deal, right? Okay, so let me try to do by hand a rough sketch of the our parabola. Well, let me see. No, not good. Okay, I need more space. The rectangular axis, like that. And our vertex is located in 2, 1, 2, and again 3, 1, 2, 3. This is the vertex. I know that this parabola open in that direction. I don't know exactly how, after we determine approximately, but I have some idea. So the focus is located here. What distance? P. And P is 1. Now the focus is here, I suppose. At that point, sorry, is 2, negative 3. This is the vertex. And the focus 1. So C1 is here, to the left, of course. This point would be 1, negative 3, no? I guess so. Yeah. It's no big deal. You know the direction. Entonces now you 1 in what direction? To the left direction, that's it. Entonces now the directrix is the same distance, pero in the other direction. Entonces es here in 3, no? This is in 1, this is in 3. It's a vertical line at x equal positive 3. Beautiful. And the axial symmetry is this line. Passing through the vertex and focus. Y equal minus 3. This is directrix. And this is axial symmetry. Okay. Finally, the endpoint of the focal diameter is in the same line of the focal, pero in this case is 1 up, because P is 1. Entonces 4P is 4. 4P is 4. Entonces 2 here and 2 here. Entonces our parabola definitely look like that. Okay. However, I want to find in detail this point and this point. No? This point would be 1, negative 1. I guess so. Yes or no? This point. 1, negative 1. And this point would be 1, negative 5. No? Negative 5. See, negative 4, negative 5, because it's 2 down from 3. This is the famous endpoint of focal diameter. Okay, entonces we forgot something. No. Vertex here. Focus here. What is the focus? I write the focus. No, I forgot the focus. No, the focus was Located at the point 1 comma negative 3, no? 1 comma, yeah. Yeah. One more information we need, directrix, this equation, vertical line, axial symmetry, this equation, horizontal line, endpoint for the focal diameter, this guy. End the story. We finish. Any question? Look like acceptable or complicated?
No, it's clear.
It's great.
All right.
That's all right. Okay, let's move into the decimal to see more clear the double checking of this. Okay, okay, okay. Okay, entonces now this is the example number 3. Boom, wow. Look at the equation. X, y plus 3 squared equal minus 4, parenthesis, x minus 2. In this case, b is negative 1. We found that. And h and k are 2 and 3, no? Negative 3, sorry. But let me check and see if I make a mistake or not. 2 comma negative 3 is the vertex, yes. Okay, good. Now, what kind of parabola we have when you have horizontal, no? Horizontal parabola, boom. Look at that. This is my graph in detail. Vertex 2 comma negative 3, good. Focus 1 comma negative 3, good. Endpoint focal diameter 1 comma negative 1, 1 comma negative 5. And equation for the directrix is x equal minus positive 3, sorry. It's 2, 3. And equation for the axial symmetry is y equal negative 3. Negative 3 or negative 2? Negative 3, no? It's negative 3, right? It's negative 3? Yeah, it's negative 3, of course. It's negative 3. I don't know why I put in my paper negative 2. Super. Any question? Do you see clear now? And we can use always this script of Desmos, okay, create for my students. Okay? One more example. Opinion, guy. Everyone follow me?
Yeah, it's clear.
Okay. Example 4. Okay, example 4 is a little bit tricky. Okay, it's the typical example that you want to put in the test. Okay, I have no idea. When I see, wow, this is, what the hell is that? I don't know. I don't know anything. But I believe que es parabola. Because parabola is the only conic sections. Ellipse, we have 3 conic sections. Ellipse, parabola, hyperbola, that we study next time. Maybe today we start a little bit example of this. Ellipse is classical x squared plus y squared. Well, divided by something, no? It's not important. But you see that x and y are completed and both squared. Entonces no ellipse, because I see a square here, pero no square here. Entonces es obvio que no ellipse, you see? When you see that we have a square, hyperbola is similar to the ellipse, pero minus. This is the formula of hyperbola that we study in a few minutes, maybe today. Entonces no, because I see que es positive. Bueno, es negative here, pero we have no y square. Discard. No. The parabola is the only conic section que you have two possibilities, no? 4px y or y squared is equal to 4px. And this equation you see que one variable is squared and another no. You see, in this case, x is squared and another no square. Okay, so you see, maybe you ask by yourself, what the hell is that? And what the hell is that? No, this is just that you identify que parabola. This is clear or no? Let me know.
Yeah, it's clear.
It's clear, right? So the only conic section que one variable is a square and another no is a parabola. So you have two square, maybe it's ellipse or maybe hyperbola. In hyperbola, well, what is the difference between hyperbola and ellipse? Hyperbola is plus, ellipse, hyperbola is negative, sorry, and ellipse is plus. Entonces now, maybe the reason I don't see clear is because I need to modify using algebra this equation to this equation. X minus h squared is equal to 4p y minus k. Okay, in this case you have x squared, y no square. I need to manipulate. Definitely, I need to manipulate. So you separate the x part and the y part. So you separate the x part and the y part alone, like that. This equation doing, and you see that part. I can factor out 4 x squared minus 5 x. Here I complete the square because I see I need to form a one trinomial here. And when you factorization, give me that part square. Entonces now on the other side, not necessary here, I move everything to the other side. And I have a y minus 57, no? Okay, super. I have another box here because this box balancing or compensating the information that we have here, right? And remember the formula to complete square is b over 2 squared. Always is the same formula. And b is 5 in our example. 5 over 2 squared is 25 over 4. You put here 25 over 4. This is the magic number. Can complete the square. 25 over 4. Entonces, in order to put in the other side, be careful because we have 1 multiplied here by 4 to say it's 25. You understand this or no? So the organization is clear. The organization is you separate the x and the y. I recommend x in the left, y in the exactly in the right, like it look like in this equation. In order to convert like a trinomial, because actually we have binomial, you using the technique of the completed square. So you take 5 divided by 2 squared 25 over 4. Okay, so now when you introduce artificially that number, it is 4. This is x minus a square root of this guy, get 5 over 2 squared equal ay minus 5725 together is 25 minus 57 is 32. Wow, negative 32. Leave it like that. No, because I see a is common factor out 8, and we have y minus 4. And we little by little you approach it to this equation. In this equation, the coefficient is 1. You divide by 4 here. You divide by 4 here. You divide by 4 here. So we have x minus 5 over 2 squared is equal to 2 times y minus 4. Wow, much better. So this equation is 100% algebraically equivalent to this. because the only thing that we are doing is completing the square. And you introduce artificially 25/4, but you introducing 25 in the other side to say the equation is equivalent. It's the same equation. This is more clear now in this equation. Okay, no problem. I understand. Do you understand this this algebra? Oh no. Come on, guy.
So the 25
Uh-huh.
you get from the subtracting 25 over 4 to the right hand?
No, in the right hand, I did negative 75 minus 57, get negative 32. So this and this together is negative 32. Okay, copy here, right? Clear the idea or no?
Oh, okay.
Uh-huh.
Yeah, that's clear.
Entonces now I factor out 8 and divide by 4, stay 2. Okay, entonces you compare this equation and this equation. Look like similar, no? Except that the vertex, where is located the vertex of this parabola? The vertex of this parabola. I need help. Remember, the vertex is always h comma k, no? In our specific example, who is h and who is k?
H is 5 over 2.
Okay, 2.5. You write like that, or you write in decimal 2.5, comma, positive or negative?
Positive.
And the k value?
4.
Exactly. This is the position for the our vertex. Nice. And the focus, well, P. What about P? What about P? What is the value for the P in this example? To say you determine, look, you determine for P is equal to 4P is equal to, therefore P is 2 over 4, que 1/2. Okay, good. Entonces, in this parabola, okay, I forgot the most important part. This parabola is a vertical parabola or horizontal parabola? It's vertical or horizontal? This is the first thing you should do, classify. Is vertical or horizontal?
Vertical.
Vertical, very well. In what direction open?
Opens up.
Oh, how do you know it's up?
The P is positive.
Exactly, because P is positive. Very well. Don't open up like that. And this famous point, get the bird, is this guy. The focus is inside here, P distant. So you basically adding, so the focus is 2.5, comma something, comma 4 plus 1/2 gets 4.5. It's the point, guy. 2.5, 4.5 is the focus. Makes sense, right? The idea elementary sketch here. And directories is the line like that. Passing through the distance here is P, que P is 1/2. So the directory is at the line y equal 3.5, no? Because the focus is in 4. 4 minus 0.5 is 3.5. And the axis of symmetry is this line. Is x equals something, is x equal h, and h in our example is 2.5. Yeah, 2.5. And the endpoint of the focal diameter is a little bit more complicated. But let's do it using the grip of decimal. Is 3.5, 4.5, and 1.5, 4.5. The problem is the decimal, you know, but it's okay. It's okay. All right. Any question in this manipulation, guys? I probably again the review packet we go over again to this, no? But it's important. I know, and in this level you need to remember very well complete the square. No? Okay, let's do in decimals. What are the answers? Okay, do you see decimals? Well, in this example, age is 2.5. 2.5 over 2. But let me delete everything. Delete everything. Okay. K is 4. Positive 4. And P is half, so 0.5, positive 0.5. 0.5. Okay, click here. The thing we're doing is problem number 4. Parabola, no? Parabola number 4. Parabola number 4. This guy. Let me see, where is this? Oh, there you go. Is this? Let me see the equation. The equation I copy was the original. I can use in the original, not necessarily. I manipulate in the piece of paper. However, in this no. So this we have vertical, no? Vertical parabola, right? Vertical. Boom, boom. Look at that. Vertex 2.5, 4. Focus 2.5, 4.5. Endpoint focal diameter. Directrix and axial symmetry. 2. Fantastic. Any question? No?
No.
Okay. Let's do one more example. You see whiteboard, right? Example 5. In example 5 is a little bit weird because give me information about focus. The focus, no equation, no. So you need to use in your imagination, do roughly sketch by hand in the piece of paper. 1,2 is the focus located. And directrix line is line x equals 7. Okay, by the way, is a vertical line. Okay, so we expect what kind of parabola we expect. See, directrix is vertical. What kind of parabola we expect? Horizontal parabola or vertical parabola?
Horizontal.
Exactly. Horizontal. Entonces I have no clear the information for the P. Entonces PP is important because give me in what direction, no? Open. Ya sé que es horizontal, pero I don't know si es in this direction or in this direction. So now I try to do a roughly sketch by hand. This is X, this is Y. Yeah, I plot both information can have. Focus 1,2. 1,2. This is the focus, 1,2. And directrix is 7. Wow. 2, 3, 4, 5, 6, and 7. It's a line like that. X equal 7. So this is the distance que es, this distance is 6, no? Because 7 minus 1 is 6. And this distance is 2p, no? 2p, remember. We have here the focus. And this is horizontal, no? Horizontal, but what direction you believe can open? In what direction you believe can open? To the right or to the left?
To the right.
To the left, very well. To the left, very well. Because I know here and directly here. Makes sense when you put every pieces to say matching perfectly. Okay, and this distance is p, I know. And this distance is also p. So the p plus p is 2p, and 2p is 6. Where come from this 6? 7 minus 1, no? Okay, you don't care the y value, no, the y value give me this component, pero no. Entonces p3, pero actually es 3, pero es no 3, es negative 3, because I know que this parabola open in that direction. Entonces now, this is my directrix. I suppose que this is my axial symmetry, the line y equal 2, and the vertex lie exactly in the middle. Here, que es 1, 2, 3, is 4, no? So the vertex is located at the point, vertex is located at the point 4,2, no? Here is the vertex. And my parabola open in that direction. I don't know exactly how, because I don't know the focal diameter, but this is it. But at least I have one reference. However, you need in this question, question, the equation of the parabola that satisfy this requirement. This one, bang, and this one, bang. When you determine que es horizontal, you determine also que open to the left. Okay, super. And I determine also que the vertex located at the point. So we are ready to set out the equation. The equation is, let me see, let me try. The equation is, bueno, let me write. This is y minus k squared is equal for p, parenthesis, x minus h, no? Something like that. Who is k? No, k is, look, this is the vertex. This is h, and this is k. So k is 2, h is 4. Super. And what about 4p? 4p is 4 times 3, que is 12, but actually it's negative 12. Okay, and this is my question in the story. Do you see it's easy? So you, at the beginning, don't know anything. You start doing the sketch. Remember, I repeat one more time. This part of the conic section, some book is called analytic geometry, because the solution you are doing in the piece of paper geometrically, doing the sketch. So you see P in one direction, P in another direction, open in the other direction. Okay. Let's see in Desmos this equation. Let me see and decimal this equation. P is -3. Actually, P is -3, no +3. Si you put +3, open to the right, it's open to the left. Entonces now is okay. Do you see this one, right? Okay, forget about this part. We are doing example 5 of the parabola. Oof. Let me see. What is this? Slows. I don't know because I need to select inside. Gone. This is my parabola in green color. However, to verify the point, I put P as -3. Boom. K and H. Who is H? A is 4. And K is 2, no? Okay, ready. And what kind of the hyperbola classified horizontal, no? Horizontal parabola. Boom. Look at the point. What point is given at the beginning? The focus given at the beginning. Look. The diameter is given at the beginning. And you determine the vertex and the midpoint. And this is the focal diameter, 1,8 and 1,4. Super. Any question, guys? It's easy or complicated? This is border. The teacher, I suppose you need to take calculus, no? You take calculus this next semester or you waiting for the fall? Come on, quick conversation. You take do you see my face now? You take a calculus or you need to take trigonometry first? How many students I have? The students sign it and leave. John, Micro, Rolando Izquierdo, Rodolfo Perez. Come on, guys, say present.
Oh, present.
Who are you?
Present, sir.
John.
Micro. Okay, John. Okay. Rolando
Sorry,
Izquierdo.
Professor. I was on a call right now, but I'm present.
Okay. Rodolfo Perez. Anthony. Irizarry.
Here.
Rodolfo no. Rodolfo is sleeping. Keylon. Lino. Anthony Suarez.
Okay.
Nermen Bader.
Present.
Matilde Moyo.
Present.
Matilde is my favorite student. She get 100 in everything. Diana Marina Rodriguez. Diana Marina. Diana is sleeping, right? Diana, I'm sleeping. Unbelievable. Okay, entonces now let's spend the time. We have 5 minutes, only 5 minutes, to do at least one problem of the hyperbola. Hyperbola. We have only 3 connect sections, guys: ellipse, parabola, and hyperbola. Hyperbola. Example 1 on the hyperbola. Well, no. Let me try to explain some theoretical part of the hyperbola before the example. I finished with the theoretical, no example. Okay, hyperbola have 2 branches. Hyperbola. 2 kinds of hyperbola. Again, horizontal and vertical. We have 1 kind of hyperbola like that. Hyperbola have 2 branches. This is the graph of the hyperbola. Not like a parabola que is only one. No. Or ellipsis closed figure. Hyperbola have two branches, and both branches belong to the same formula. Okay. And we have another kind, just like that. This is horizontal. Why not? It's the way I like. The book, no. The book called different. And this is vertical. This is shortcut. So how do you know that? Well, actually, we have two axes of the hyperbola. This is hyperbola. We are talking about hyperbola. We have two axes. The most important axis is this, que es transversal axis. In this case, no. In this case, it's like that. Transversal axis. We have another axis here, just call it conjugate, but it's not important. The most important is transversal. And how do you know the position for the transversal? Well, depends on the equation. For example, this hyperbola, the equation is x squared over a squared minus y squared over b squared. It's important, guys. It's important. Equal 1. In the hyperbola is minus. So you have x squared over a squared plus y squared over b squared is ellipsis. Okay, ellipsis. In this case, no. When it's minus, it's hyperbola. Always. And when the x is positive, that indicates that the transverse axis is coincident with the x-axis. Okay. And this no. This is y squared over a squared minus x squared over b squared equal 1. In this case, the positive part of the equation is associated with the y. Therefore, that means that the transversal axis is or coincident or parallel to the y-axis. Okay? Entonces you see something weird because in the ellipsis, entonces the student confusing this. In the ellipsis, always A is the major axis because A is the big number. In the hyperbola, not necessary. So A is always associated with the positive part. You see that intentionally I put A in the X here and A in the Y. So A is a number associated with the positive part. Maybe X or maybe not necessarily the bigger number. Okay, this is the differences, a small difference because students don't organize in your mind to understand this. And what is the A? Well, the A is that distance. Look. So we have the center. We have center. Center always is at h, k. Si no specification h and k like this equation, bueno, es origin 0,0. And this distance is A. A in that distance and A in that distance. So it's A and negative A. So si this point is 0,0, this point would be A, 0, and this point is negative A, 0. And this point, and this point, let me use another color, is the vertex, in plural, vertices, two vertices. And this hyperbola, well, it's the same, but the transversal axis lie in the Y, and this is the A distance. Look. And this is the A distance. So this vertex is located at the point 0,8, and this point is located at the point 0,-. Makes sense, right? It's And what about focus? Well, we have two. En plural, cuando we have two is foci. And the foci is located on the transversal axis, but the focal distance is C, similar to the hyperbola. and C is bigger. Is this segment? This is this segment. This is the focus number 1, and this is the focus number 2, and this distance is C. C. Okay, by the way, in this case, it's different to the elixir because C is bigger than A and B. I want to see the mathematical relationship. In this case, the foci is C equal here. This is distance is C, focal distance, and this is 1C. And the focus is similar to the parabola, it's located inside. So never you see focus here, you see focus inside. Okay? Okay. And that's it? No. We're more complicated. And what about B? Bueno, the matemática que conecta ABC es different to the matemática que conecta elixir. The bigger is C, entonces C squared is equal to A squared plus B squared. This is for hyperbola. Compared with the elixir is different, it's A squared is equal to B squared plus C squared. Because I need to know the elixir, the major size is A. And the hyperbola, no, the big is C. Entonces, what is the role of B? Okay, I don't see geometrically or anywhere. Well, we have the hyperbola have also, this is most complicated, not complicated, but it's weird. Two asymptotes, two oblique asymptotes, like that. Let me show you. Actually, the curve approach it but never touch. So this is not good. Let's approach it here. I like Y here. And the equation of this asymptote is a line. Is Y equal plus and minus B over AX. The slope of this line is B over A, one positive and one negative. No, the positive is the line is going up, and the negative is the line is going down. No, negative. And entonces to do this, my recommendation is always do something que is called reference rectangle. Reference rectangle. It's one rectangle like that. Boom, 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 boom. And the dimension for this rectangle is 2A, and it's a 2B. In other words, it's B to the right, A to the right, A to the left, B over, B down. And you get the triangle, and you connected the diagonal, and you are doing perfectly the asymptote. What is the difference when it's vertical? The equation is a little bit different. It's Y equal plus or minus A over B. It's a reciprocal. Boom, 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 boom. This is the asymptote. And this is the A and B is this segment. And B is this segment. And you get that, or this B and B. And you have the famous reference rectangle. So I promise the next class we'll practice hyperbola in detail. Okay, important. What kind of hyperbola? Depending on who is positive, who is negative. It's easy. Okay? See, the X is positive is the transversal axis lie on the X axis, therefore is horizontal. Well, we continue next time. Okay, guys? Have a nice day.
Have a good day, Professor.